Welcome to homework.
Okay, we want to generate the following molecule via a Williamson ether synthesis, and we need to select what the best reagents for that would be. And recall what that typically means when you're doing a Williamson ether synthesis is that you want a small alkoxide, right? And you need to have a substrate, a matching substrate, which is capable of undergoing SN2. Right? Because what you're looking for is a alkoxide, right? Which can, I'm going to put Lg for leaving group, attack a carbon, leaving group leaves, and you generate the ether that corresponds to the substrate carbons minus the leaving group and whatever structure you had attached to your alkoxide. Okay, so we've been given basically the following thing to determine. We've got to say, are we saying that our alkoxide looks like this part of the molecule, or does our alkoxide look like this part of the molecule? Okay, so those are two options. So I'm going to sketch those out. We're going to say, are we looking for an alkoxide like this, right? Or are we looking for an alkoxide like that? And then corresponding to each of these would be the component part that would give you the rest of the carbon chain. So if this is our alkoxide, then we've got to have a leaving group, a substrate with a leaving group that looks like this, whereas for this alkoxide, we need a substrate with a leaving group that looks like this, right? So those are our possible pairs. If we look at our list of structures that contain a leaving group, the one that corresponds to this is P, and the one that corresponds to this is, we may not have one, and that could be kind of the option that tells us that we don't. Oh, there, no, we do. It's M. Okay, and the alkoxide that corresponds to this would be G, and the alkoxide which corresponds to this would be D. Okay, so is it going to be D and P, or is it going to be G and M? Okay, so let's classify these. Here we have a sort of a secondary alkoxide, right? And a primary leaving group. Okay, here we have a secondary substrate with a leaving group and a primary nucleophile, right? Well, if you recall, in terms of SN2 reactions, it's more important that the substrate with the leaving group be primary, right? In terms of reaction speed. Second, primary alkoxides will participate in SN2 more quickly than primary. However, the extent to which primary substrates will undergo SN2 is far greater versus secondary substrates is far greater than the difference between primary and secondary nucleophiles, right? Or alkoxides specifically. So for that reason, we would prefer to have our substrate with our leaving group be primary and our nucleophile be a secondary alkoxide. Therefore, the winning pair is going to be GM.